There you go.
All right. So anything else, Justin? Any other intro, or do you just want me to start speaking?
Okay, so let's see. So this is my older brother, Scott. He's 3 years older than me. And since we left the house in Michigan, he left college and never returned. In fact, he didn't just never return to the house. He started out in Missouri, went to Georgia, South Carolina. Right now he's in, well, technically lives in Boston, but has anyone ever played Where in the World is Carmen Sandiego? Maybe
Oh
not.
yeah,
That's
I
what
but I
it
heard
know
of
feels
it.
like when
I
I'm
know that.
calling. Yeah, okay. Well, that's what it feels like when I call my older brother Scott. He's always traveling around because he's a very important job. And you know how he got it and how he got all his jobs? He just kept moving up because he was able to tell people how the math, how math was related to what they're, I don't know, Scott's going to tell you, but how math is related to what they needed to do and how he could help them do it. And so he's ready to tell us all these different things about what he does, how math is involved, and then I want everyone to be ready with your questions. Whatever you're learning about this summer, you know, we want you to ask Scott how he uses it in his job. Okay? Go
All right.
ahead.
Best. So yeah, right now I'm on vacation in Spain, hence this awesome shirt. Summertime is great for vacation. It's great to be here with you guys today. And as Justin said, I did leave Michigan right away after college, just like him. That's because our dad threw us out of the house and said, go into the real world and get a job. So I did. And I joined the insurance industry in a finance role. So I went to school, college for economics, which is kind of like an applied form of math and statistics, right? Rather than just equations for the sake of equations, you have real world problems to solve. And throughout my career, and I've worked in finance, I've worked in marketing, I've worked in merchandising for an e-commerce website. I now work in insurance and in artificial intelligence and machine learning. There's been two common themes. One is, in the corporate world, what people really value, and by people I mean kind of the bosses with all the money that control raises and control the company, is predictability. So everybody wants to know kind of what is my next quarter going to look like? What are sales for next week going to look like? What's the right price for this item? If I spend money on a marketing campaign, like a television advertisement, what's the return on that investment going to be? So kind of a very common theme in my career has just been applying kind of pretty basic math, like y equals mx plus b type of linear regression to corporate data to try to bring some better predictability and better advice to decision makers. So in my first job in finance, the job was to make giant spreadsheets with equations in those spreadsheets. That was basic stuff like multiplication and division with some standard deviations, means, averages, and then plotting some sort of lines of best fit to try to say, here's what the trailing revenue was last week or last year. Here's what the revenue is going to be kind of this next year, along with expenses, along with profit. And then you have to get a little bit creative and adjust for seasonality, right? So I spent most of my career in insurance, which a lot of people think is pretty boring. But you have things like you have to be able to predict what happens when a winter storm hits. You have to be able to predict what happens when a flood hits. You have to be able to predict what happens when a hailstorm hits. Both, what's the likelihood of those events occurring, and what is the expense of that event if it does happen. So when Justin and I were talking to get ready for this, I was like, yeah, we use the Poisson distribution, not just the standard distribution. We use the gamma distribution. So all sorts of these sort of things in textbook statistics that people wonder, when will you ever use these? There's always a real world application, even if it wasn't at all apparent to me when I was going to school in middle school, junior high school. So I started in finance, and then that was kind of frustrated me because not everyone had the same rigor and discipline that I took to using data to make decisions. A lot of people, especially in the marketing department I worked with, and this was a long time ago, back in like 2004, 2005, they would just sort of say, well, we want to do the things that we've done the same way. We're going to spend the money the way we're going to spend the money. And I came in and said, well, there's a better way. Let me build an analytical model to show you. And so then I showed that, and then the chief marketing officer let me have a job out of finance, which was which was really just giving advice, into marketing, which was really kind of directing a budget. And since Justin and I are from Detroit, I worked heavily with General Motors, and like we spent a lot of time predicting who would buy our insurance and how much that insurance should be priced when they were buying new cars. And so we used data and we used math to figure out, when to target somebody, when to use marketing money to target them to have a conversation about insurance. And then subsequent from there, spent a couple of years in marketing, and then moved over into insurance pricing, which is also just a lot of math. And then from there, moved into the restaurant industry, surprisingly. And that's when we used a lot of price elasticity modeling to say, how much should we charge for a plate? How much should we charge for a fork? How much should we charge for a refrigerator? So every time you walk into a store, there's somebody behind the scenes with equations and a model that dictates how much all of those products cost, or based on how much they cost to make, how much they cost to ship, how much it costs to run that store, and every kind of the whole world that, at least that I've seen from the business perspective, is driven by math. The last couple of years, and why I get to have fun in Spain and travel to Australia and spend a lot of time in Europe and all over the world, I've moved into artificial intelligence and machine learning, which is really just computerized calculus, like neural networks, which are very popular to talk about if you read a CNN article or something, is really just calculus. It's a lot of derivatives upon derivatives upon derivatives upon derivatives, along with some multiple linear regression. So there's a lot of hype around modern machine learning and AI, but the basics of it can be really drawn back to high school math. Like if you remove all the hype and you remove all the code, you get down to just finding patterns and data, and really clever and creative ways to shape and use data. So I don't know, I guess I'd say that math is a sort of a foundational expectation for the corporate world. And then it's not just though knowing it, it's sort of understanding the problems that you're being faced with. So I want to predict something. I want to know how much to charge for a refrigerator. Well, if I charge how much for this refrigerator, how am I going to sell? What sort of profit am I going to make? How do I price an insurance policy? How do I price an airline ticket? How do I price shoes? Whatever, it kind of goes into that. It's really understanding the data so that you can create the right equation. So understanding, people like Justin who don't have a lot of hair have different different choices in shirts than someone like me who has a lot of hair, and I can get away with this flowery pattern. It's a terrible example. I forced it trying to pick on Justin, but I guess kind of in addition to just understanding the equations and understanding statistics and understanding algebra and calculus, it's really, you have to find it, if you want to go into the corporate world, find an industry where the problems interest you. So you want to go into selling clothes, you want to go into making movies, you want to go into flying planes. You have to sort of find problems that interest you, and then use the skills that you learned in high school to help you solve those problems. And that's how you kind of progress through your career, at least from my standpoint and from the corporate world. I appreciate how great of a job Justin's done finding different types of people to come talk to you about how they use math in different industries. I only know the corporate world. Sorry, Justin.
No, it's perfect. I wrote down, I was taking scrupulous notes as you were talking.
Great.
Yeah. So, all right. Does anyone have any introductory questions for Scott? Anything you want to know? Type it in the chat. Chittibum, did you want to say a question out loud?
Yeah, it was me, Chisholm.
Oh, Chisholm. Okay, go ahead.
I wasn't here until he stopped talking. But is this your brother?
This is my brother. Yeah.
Really?
Uh-huh. Yes. All right. And he's talking to us about machine learning. So raise your hand if you have an Alexa in your house.
Oh, I have Alexa in my
You
house.
do?
I have
My cousin
three of
does.
them.
I have the fourth
I
generation.
have Alexa.
Yeah,
Three of
me too.
I have
How-
three of them.
Scott, is Alexa learning things about us as we talk to it?
No, not in real time. Alexa captures all of the information, though, the voice recognition information that you speak to it, and that data gets captured, and that data gets processed by data scientists. And data scientists are people who studied math all through high school, all through college, all through usually some sort of postgraduate degree. And they analyze the data, and they change the algorithms and the equations to be able to better understand people. And one of the problems with it's a domain called natural language processing, which is a subfamily of machine learning. And one of the reasons they record so much data is because in the US you have such large regional accents. So somebody from Michigan sounds different than somebody from Louisiana, who sounds different from somebody from Baltimore. And what those data scientists are doing is they're using computers to apply math to voice recognition, to voice recordings, to be able to turn the different regional accents and the different tones in people's voices from men versus women into algorithms, into these equations, so that they can make Alexa smarter and Alexa can understand what you're asking. There's nothing more frustrating than talking to something and she says, well, could you please repeat that? I didn't understand.
Wow. And I know we have some questions in the chat, like what interested you in machine learning from Miles?
Yeah, no, that's a great question. So first of all, the software industry is a lot better place to make money than the insurance industry. So that was the primary thing. I'm highly motivated by that. But second, machine learning is just really a way to kind of automate the process of doing the math. So I started out using Excel spreadsheets, building models by hand, having to have an idea about kind of what inputs to put into those models. And really, if you think about y equals mx plus b, the equation for a line, when you get into multiple linear regression, it's a lot more complicated than that. You have to start thinking about all of the different inputs into that. And what machine learning allows you to do is automate a whole bunch of that stuff. So you can do a lot more data analysis a lot quicker. And I was always interested in maybe not weather predictions, like I saw the question in that chat, although Justin and my uncle, who lives in Maryland, it was a meteorologist, so maybe he'll come talk to you about weather predictions someday. But actually predicting the outcomes of what happens when a storm hits, what happens when a flood hits on insurance data, because that was just I didn't grow up wanting to go into insurance. It's just sort of the first company that would give me a job. So yeah, machine learning interests me because it was highly hyped and it was just a good way to kind of help me get better at what I was trying to do, which was, figure out how to price insurance better.
And Scott gave us a couple of inputs. I think the hair length was your example. That was an input, right? That we would
Which
put
one?
in when you're talking about what kind of shirt you can sell people. Like if you have a specific type of shirt, it might look better on someone with hair than someone without hair. But
That's right.
So it sounds like and even when you were talking to the people at the beginning of your career and you made the model for for finance to help your boss understand the what was going to happen in the future. Is that right?
Mhm.
Everyone just kind of wanted to do what they wanted to do. And you used math to create a model to make predictions and say, if we do this, this will happen. Do you want this to happen? Right.
That's right.
So can everyone put some examples of inputs into the chat? Can anyone think of some?
I wasn't here. I wasn't here when he was talking about that. I think I came in at the end.
Well, let me see if I can summarize. So Scott he was at work, and everyone just kind of wanted to do whatever they wanted to do. And some of the things that they wanted to do weren't very helpful for the company. And so they really needed to make a change, but they didn't know how to make the change. So Scott used math to make a model to help them see if they did what they wanted to do, what the result would be. Or if they changed and did something better, what the result would be, right? How about an input like time spent studying? Is that an input?
It sounds like a very large amount of if-thens. You know, if I this, then this would be the outcome. If this, then this would be the outcome. And there's a lot of trial and error in that also, isn't there, Mr. Field?
Somewhat. It's more that you can't make the world's not univariate, right? So the world has multiple variables. So if you're selling shoes, for example, you want to know how many what size shoes you want to ship to a store. Two inputs that you might use are gender and age. Like what are the different age brackets in terms of the population there? And you would say kind of boys and girls have different shoe sizes, and people as they grow up, generally their feet get bigger. And so you would use linear regression to say what's the proportion to males and females, and sort of how do people age through that to be able to predict how many size 6 shoes you need, 7 shoes you need, 8 shoes you need, 9 shoes you need, 10 shoes you need. If you just use if then statements, then that's a lot to manage, and you don't get at the correlation between different variables as much. So it's very similar to that, but also the mathematics side is kind of going beyond just the if then to fit an algorithm to the data to be able to solve the problem.
One other thing you had told me that you want to talk about, because as you're talking, Scott, it seems a bit overwhelming.
Sorry about that. Yeah.
No, but you said that you wanted to tell everyone about working in teams in addition to just using math, right? So you don't do this all by yourself, right? Or do you?
No, absolutely not. Absolutely not. In fact, I don't even personally do that much math anymore. I generally spend my time hiring people and asking them questions along with other people that I work with, and different people have sort of different expertise in different problems. So one of the guys I work with, he is really good at finding patterns in text. So you take something like Alexa that takes your voice. What that does is it transcribes it to text. And he's got a very special skill in being able to find patterns in that text. And then another person that I work with is very skilled at sort of taking the data after the text has been analyzed and putting it through the algorithms that can find the right equations so that Alexa can give the right answers to you. So yeah, the world is far too complicated for any one person to understand anything anymore. You have to work in large teams, and even teams with people who don't know much about math really. One of the people that I've valued working with the most are visual designers, right? Every web page, you don't appreciate how much work has gone into the layout, how much work has gone into whether that shopping cart button should be green or orange, and what are the implications of that. And so, one of the other things that's constantly going on is you use your phone, or you surf the web, or you change channels, is all of that is being measured and monitored, and people are using that data some on the visual level, some on the kind of creative, what data can I capture level, and some on the math modeling level to work together to figure out how to deliver to you an easier, more seamless experience.
So it sounds like it's like even like consequences, right? You make the shopping cart green or orange, there's a result or even a consequence for what you choose, right? And
Yeah, that's right. That's right.
and all
Yeah.
the kids, you know, they're doing the same thing. They're making choices about how much they're going to study, you know, how much they're going to pay attention. Are they going to click on YouTube, right? And they're kind of thinking, what or not thinking, right, about the results of their decisions. And isn't that kind of what you found people in the professional world doing too? Is that what you're saying?
It is, and you know, the problem with YouTube is you have thousands of brilliant people who are designing the most. They're using data and math to design the most distracting ad possible to stop you from studying. That's their job, to stop you from studying. That's YouTube's job, and that's TikTok's job. But it's Justin's job and the rest of the teacher's job to convince you to study. And it's really kind of looks like 3 on about a million. So Justin, that's a tough job.
How many people have been distracted by YouTube or TikTok during the year? Raise your virtual hand. Oh my goodness, like the hands are going up. Miss Muñeca, did you raise your hand?
I did.
Oh wow.
I am in the middle of this pandemic as everyone else is. So, you know, to push myself away from the electronics so that I can get other things done. So yeah, absolutely. Absolutely.
I mean, if you think about it, it's really math that's preventing people from studying math.
Oh gosh. Yeah.
Oh,
because
that's
they're-
interesting.
Yeah. All right. So now here's the fun part. We did this last week. Everyone type the math topic that you're learning in class. And then Scott is going to tell you how he uses that topic in his career.
While they do that, Mr. Field, Ian had an interesting question, and I just wanted to, there were some questions in the box. So I didn't, those guys, I just wanted to make sure their questions were addressed. It says, is there a specific type of problem you would like to solve more than others? Just in all of
Yes.
your,
Yes. So I've spent 15 or 20 years in insurance figuring out how much something costs after an accident happens. And I want to use machine learning and data to help people not make those accidents in the first place, right? It's much better. It's one thing to give somebody money to put them back together. It's much better if you can prevent them from getting hurt in the first place.
All right. So I see inequalities.
Oh, yeah.
SAS and SSS?
Triangle congruence, shifting functions, transformations of functions, mixed numbers.
Inequalities, factoring trinomials and lines. A bit. He's like scratching his head.
I remember these words. Let's see. Triangles and, factoring triangles and figuring out all about triangles. Well, I don't do that personally. Triangles and trigonometry and all that's how this whole display is calculated. So when computer programmers are figuring out how to draw a visual on a screen, this is all a bunch of dots, right? And all these pixels, especially in video games, not so much in computer monitors, but like the PlayStation 5, for example, that the reason the graphics are so great is it's calculating, I think it's something like 5 billion triangles per frame, and it has 60 frames per second. And before that, it was only about 1 million triangles per frame. But it's all trigonometry. It's all equations to set up how to calculate all these little triangles with different colors behind the scenes, just using computer code and instead of using it by hand.
That's amazing.
Yeah.
All right, Scott, you're 1 for 1.
There we go. Yeah, there's a lot of things in here.
Yeah.
3D shapes, also trigonometry. Adding decimals and fractions. Decimals and fractions, very important in the world of finance. Incredibly important. Everybody hears about Wall Street all the time and how greedy Wall Street is. So first of all, they're right. Those guys are very greedy, but the math they're doing is not that much more complicated than decimals, fractions, multiplication, division, and then a little bit of statistics thrown in there.
That's all the people
Shift
on Wall
function,
Street are
Mr. Field.
Say that again?
What's a shift function?
A shift function. So if you have y equals x squared, and
Yeah.
then you have y equals x squared minus 2, then
Yeah.
it's just the same function shifted down 2.
Oh, so that would be something like baking in seasonality to a prediction.
Oh,
So you'd be like, okay, well, y equals x, but what's the average temperature for that month? So you could be trying to predict the likelihood of an ice storm, and you have the average precipitation and the average temperature, like in inches, and then you have the average temperature, and then the min temperature, and then the max average temperature, and that will help you predict the likelihood of an ice storm much better.
so if everyone, there's a question for the kids. If everyone, if the store has a certain function that they use to predict how much money they're gonna make, right? At the mall, a store at the mall, what happens during Christmas time? Do they have to shift that function up or shift it down? What do you guys think? And why? Algebra 1, algebra 2. Anyone raise your? Did I stump you? Down, Ronan. Why do you say down? You could say it out loud.
Because it's Christmas.
What
And
happens on Christmas?
prices-
People buy
prices go
more
up.
things or less things?
Before the month
Yeah.
before Christmas, not Christmas itself. What about the month before it?
Yeah. Why you say up, Jalen?
Because more people are trying to get stuff, so they can, and like there's more demand for everything, so they push it up.
Yeah. So they might have a profitability function, but they need to use a transformation in their model to adjust it for the seasonality, of the holidays. Is that right, Scott?
It is right, and it definitely goes up.
And then does it go down in January and February?
So sales go down, but what do you think goes up, Mr. Field? We'll put you on the spot. What goes up? What if sales go up? What goes up in January after sales go down?
If sales go up,
In
Wait.
December, but down in January. What's the opposite of sales?
inventory,
Returns.
returns. Oh,
Yeah.
oh, so then
Return.
is that a different function though?
Well, it depends on if you're modeling total revenue or total profit, or if you're just modeling sales. So total revenue would be sales minus returns.
Uh-huh.
So revenue doesn't just go down in January because sales goes down. It also goes down because returns go up, because it's a negative part of the equation.
Aha. There you go. See, there's the different inputs to the function.
I'll give you a B- on that answer.
I guess that solves our little dilemma.
It's
Yes,
more
it is.
fun putting people on the spot than being on the spot.
Oh, sorry.
Yeah.
All right. Place value. Michelle says place value.
Yeah, some of the younger kids, I was happy that you mentioned, adding and subtracting decimals, you
I
mentioned
said
multiplication, place value. We have students here that are second grade through sixth grade who are, working still on some of those numeracy, skills. So what are your thoughts on that? How much of this do you use in your world?
Well, I just used that twice, eating lunch before I came here, because I had a certain amount of money that I took out of the bank and I didn't want to take out any more. So it was helpful to decide which pizza I ate, since it's late in the afternoon here, not early in the morning, with just the money I had in my wallet. So
There you go. So
very helpful for day-to-day living, not just the work world.
Yeah, when we get down to adding in some division with remainders. Oh my gosh, Chisholm is
I can't do
shouting.
long division. Long division, I can't do that. I'm sorry.
Really?
Nope,
What?
it's impossible.
I used to do it, but then I forgot it. So I used to do long division, but then I forgot it.
Hey, if you can do long division, you can be a CEO. That stuff is crazy.
Practice and multiply and divide using partials, partial products, partial. Yeah. All right,
Yeah,
let's.
It's multiplying and dividing. But at the same time, you also said that you hire people. And
Yes.
that there are people around you who have those math skills that you don't necessarily master, but they do. And they're in there helping you with these calculations and these predictions and creating these plans for these companies, correct?
Yeah, that's right. And to the question in the chat, yeah, we would use decimals in the corporate world rather than remainders.
Absolutely. You guys don't talk in terms of mixed numbers?
Not typically. I mean, no. Stop there.
Yeah. Subtract mixed numbers, expanded form. Oh, what about factoring trinomials? I saw Ronan asked about lines of best fit, but you told us about lines of best fit
Yeah.
a couple times. But do you ever find any aspects of, you remember how to factor? I'm sure that's
Nope.
been a while too.
Nope.
That's when you take x squared plus 5x plus 6 and you turn it into x plus 3 times x plus 2. But so there's, well, maybe
There's many different types of math.
And they're sometimes very confusing.
Mhm.
I agree.
Yes, absolutely. Place values and decimals, we got that. All right, does anyone have any other questions for Scott, just related to how he got to where he is, how many countries he's been to? Any more fun questions since we put him on the spot
Actually,
with all the
yeah.
math?
You have
Go
a few
ahead,
hands
Susan.
up also.
I wanted to ask you what the same question Mr. Field said, like how many countries have you been to?
Probably like 15.
That's
Oh.
a lot of
San Diego can go to like 50.
That's a lot of countries. Is when you went to those countries, were you beginning to start learning machine math when you were traveling from country to country?
Yes. So when I went into machine learning, I started working with global companies. And so my company sent me to Australia. They sent me to Switzerland. They sent me to Japan. They sent me to France. They sent me to Germany. They sent me to Canada, which wasn't that interesting. They sent me to New Zealand, all over the place, because I studied really, really, really hard. And I used to, in the morning, I would run and I would listen to podcasts on machine learning. I would read academic papers at lunch. And it was something that I wanted to be really, really good at. So I applied myself, and then, the part of the reward was not just kind of getting a good job and a nice salary, but also it's just, they paid for me to see the world. And so, a question for you guys, if a plane ticket costs $2,000 or a plane ticket is free and costs $0 because your company pays for it, which one's cheaper?
Okay, how did you, as soon as you started learning machine math, how did you get smarter every day?
Practice. I was so confused for the first year. I had a headache every day. You just have to read and reread and read the same thing and do it by hand until you understand it. And it's so funny with math. You go from, I'm never going to understand this at all. I'm completely confused. To
Some-
when the teacher
some-
explains it, now I can understand it. But then as soon as the teacher's not talking to me, I kind of forget. And then one day you can just do it. And I don't think anybody kind of knows how it goes from I don't understand this at all, I'm so confused, to I understand this. But it all comes through just, you know, work, the same, and repetition, the same way you get better at a video game, or the same way, you know, you learn to ride a bike.
That's a really good point. I want to say something about that, but Titus has a question too.
Oh yeah, sure.
You have a few questions in there, Mr. Field.
I see
Okay,
that.
so we were talking about
Right.
Alexa earlier, right?
Yep.
Mhm.
Okay, so it's always listening to me, right? And Google and everything else always listening to me, right? How do I get an ad 2 hours later about what I'm talking about? I was talking about trampolines and I see an ad
Right.
trampoline 2 hours later. I don't understand.
Touche.
They're always listening.
Yes.
That's right. So that's marketing. That's marketing people working with data scientists. It's a very complicated chain. So they're listening to what you're saying, and then they take that data, and not as much in real time, but that data is sort of sold in an auction. You know, an auction, somebody puts their hand up like, oh, you know, you're talking about trampolines. This company says, I'm gonna pay $3 to be able to put an ad. And this other company says, I'm gonna pay $5 to put an ad, because, you know, he's not just talking about this, but I know where his location is, and I know the type of phone he uses is an Android, or I know he's an iPhone or something. And so it's not just what you're saying, it's also the data they're collecting about you, that companies behind the scenes are paying Google money and paying Amazon a lot of money, which is why those services are free, so that they can try to better sell you things. When I went into marketing 15 years ago, that was one of the first things I did. It's called search word and keyword optimization. So based on what you type into the web browser, this is before voice, but when people used to only search through text, you know, we would have huge equations that weren't just what you were searching for, but also data about you that allowed us to bid for the right to put an advertisement in front of you, in hopes that you would click on it and buy something. And it works in aggregate. You know, most of the times companies fail. Most of the times you don't buy what you're talking about, but it works enough that Google and Amazon have made nice businesses off of it.
Did you click on the trampoline ad, Titus?
Oh yeah, of course I did.
Right. And how? Jaden, question. Jaden? Unmute, buddy.
So do you like work for like machines, or like what do you really want to do? Like what do you want to work on? Like what's your goal on work on?
Jaden, you might want, I don't know
I
if you
think
got
what
that
he's
stuff.
asking is, what's your ultimate goal? You know, you've
Okay.
done all of these things, but what he's asking is, what is your ultimate goal? Jaden, is that what you're asking? What's his ultimate goal at the end of all this experience? Yeah, I think his computer's acting up.
Yeah, so people never stop learning, especially the curious ones. And so I, just like Justin likes teaching, I like teaching as well. So I like hiring people. I like talking to different people in my industry and kind of educating them on different points of view. You know, this week right now I'm in Madrid, Spain, enjoying vacation. Next week, like I'm talking to you guys, I have to go into a recording studio in London and film a video interview about applying machine learning to insurance data that's going to be published to a whole bunch of people in Europe. So, you know, I'm sort of past the point of selfishly wanting more for me and more just enjoying helping younger people learn and you know, grow their skills in machine learning.
Nice.
And
Samuel had a question, Mr. Field.
Go
Okay,
ahead.
so I wanted to ask, what What did you study in college to get the machine learning? What course did you take?
So I studied economics and statistics. But that's because I went to college probably before most of you guys were born. A lot of people now would study data science directly. So you would study statistics as the foundation. Economics is very helpful. Calc 1, Calc 2, and then some sort of programming language like Python or R, and applied data science to start to learn it.
Does the world need more data scientists?
The world needs more thoughtful data scientists, people that just don't get in it to learn to code, but people who get into it because they are really passionate about something that doesn't necessarily have to do with math at all. Math might not be your passion, but math helps you, improve, the outcome that you're seeking to improve, whether it's, insurance, whether it's medicine, whether it's whatever. Math is not just a skill for the sake of math. It's a skill that helps you kind of help other people in a very structured, programmatic way.
Thank you, Scott. Do you see any other questions, Ms. Muñeca?
Yeah, Miss Charity had her hand up, but I wasn't sure if she was right in front of her. I know she was there like a second ago. So Miss Charity, if you come back, let us know. PJ had a question, and I think Titus was taken care of. Titus, did you have another question?
Not now, not right now.
Okay, no problem. Ian, did you have a question?
No.
Okay, I think some of these you answered. On, did you have a question? Shireen or Caitlin?
Oh, I see.
Yeah, some of them you answered as we went on.
Don't forget to lower your hands, guys.
Yeah, I know. That's why I was like, okay, make sure we got everybody. Yeah, I think we're good.
Okay, we have Scott for just a few more minutes, but I just wanted, what you said about learning math, I think was really helpful, and no matter what age, we all can relate to it. That you said, you don't know how to do it, then you get to the point where the teacher tells you and you understand it. How many people have been to the point where your teacher tells you and you understand them, but then when you try it on your own, you get confused again? Raise your hand if you've ever been there.
Oh.
Yeah. Okay. Now, I know Scott said that he writes it down and keeps trying it. How many people are writing down the work that they do? Or are you just clicking on the computer?
I'm so glad you brought that up, and hopefully Scott can talk about that, because mental math in children is prevalent. And it's the hardest thing as teachers to get our students to stop trying to do it all up here and do it on here, because, that's a lot to keep up with, and that's where mistakes happen. So I would love to maybe hear you say a little something about how do you keep track of the math you do?
When you're learning something new, it's really hard to do it, I think, at a computer. Screens are just distracting. Well, so in the corporate world, the walls are whiteboards. And so, I mean, basically, I some days I feel like I just draw on walls professionally for a living, because you're trying to work out the problems by writing. And sometimes a pad and paper is good, but most of the times, you're collaborating with a group of people when you're solving new problems. So you're just take a marker, just like start writing out what the problem is and doing the math on a wall, kind of walking around, pacing around until you sort of feel like you've solved it. And then you have to kind of take that back and write the equation in the model, whether it's in a spreadsheet or in Python or something.
How many people like writing on the whiteboard at school?
Oh, yeah.
Samuel, Alec, that's good. You can tell your teacher, hey, I want to be a professional. I need to go do this on the whiteboard. That's what they do at the corporate world, in the corporate world.
Just don't use a permanent marker.
Well, see that, but if you use a permanent marker, you just write over it with Expo and it erases right off.
And it erases it, right? I know, Charity, you had a question. Did you want to ask your question?
My hand was raised from being distracted by TikTok and the internet, and I never put it down.
Okay.
What was your question, though?
I didn't. You remember when he asked who?
Oh, right.
Oh, okay.
Yeah. Oh, are you saying you've been distracted by TikTok and the internet?
Yes,
The algorithms are getting you too?
yes.
That's good.
They get all of us, kind of.
That's so true.
It's about
Is there any
breaking
way,
enough.
is there any way out of it?
Well, that's why I go to the whiteboard. I honestly, because if I'm at a computer and if something gets hard, I'm like, oh, I'm just gonna alt tab and go to check the sports scores because it's so much easier than figuring out something that's hard. So that's why, me personally, and I'm not like preaching to you guys. I'm just saying, like he asked me the question. I put the phone down, I walk away from the laptop, and I just stand there in front of a wall with a marker and work on the problem or get an ad blocker. That works too. And getting an ad blocker doesn't work for me though, because when I'm frustrated, the last thing I want to do is sit in front of a computer without, going to Reddit or going to ESPN. But closing it and walking away, writing something down with just you with a piece of paper, maybe some music helps me concentrate. A lot of times actually, when I'm working on something really hard, if I don't have music on in the background, it's hard for me to concentrate. But music sort of distracts my brain just enough that it's like, okay, I'm kind of having fun. And so now I can focus on what I need to do versus if I don't have music, then I'll just be like looking around, totally distracted at all.
How many people can do that this school year? Just if you get frustrated or distracted, close your devices and go to the paper or even get a whiteboard. How many people can do that? Michelle, that's good.
Glad you pointed that out, Scott. Absolutely. There's nothing in it. Yeah.
All right. Well, Scott, you were amazing. Thank you so much for coming, helping your little brother out, and sharing all that you've done with math. Does anyone have any last questions before we let Scott go? Get back
I
to
have
his
a question for the
vacation?
class, Justin. I
Go
want
for
to
it.
know who they think looks younger.
Oh, okay.
Mr. Field.
God.
Mr. Field.
Mr.
Not
Field.
Mr. Field.
Scott.
Mr. Field. Mr.
Field.
Field.
Mr.
Scott,
Field.
Scott,
It ain't fair.
I'm on the
Mr.
Mr.
Field.
Field
Mr.
hat.
Not right.
That hat.
It
Mr.
might be there.
No.
Mr.
That
Field
was
is the youngest.
That was
I'm just
great.
gonna press mute for a second on that one.
Yes.
You know what? Kids are stressful, okay? So I'm gonna have my third kid, and Scott is having a baby in November. So you just wait. You just wait. Then we'll be even.
They said Scott in the chat.
Or either that or you'll both be bald, one or the other.
Who's actually younger?
I'm 3 years younger.
I knew it.
told you. The people said Scott. Ha ha.
Yeah. I'm 36 and Scott is 39. My oldest brother Eric is 40.
All right.
And he looks older than all of us.
Wait, you have another brother?
I do.
What's his
But
name?
Scott, yeah. But Scott's the one you get to meet this time.
What's
So
his
everyone
name?
say thank you, Scott.
Thank
Thank
you,
you.
Thank
Scott.
you, Mr.